All right, here we go. Lesson 1.7. Let's take a look at this. So task 1. Which one doesn't belong? As we know, with all these which one doesn't belongs, or whatever you want to call them, every single one of these has a reason that it doesn't belong. Sometimes more than one. So the question is, what are they? So let's take a look here. Looking at this, the very first thing I would notice is that this one's green. So this one's shaded green. So that's one reason why A wouldn't work, right? Let's see here. What else can we notice? Oh, this one here, this one's blue. Has a blue outline. All the rest have black outlines. So that's different that way. What else? Well, this one has 4 sides. This one has 4 sides. And this one also has 4 sides. So that must mean that this is the one that is not the right one. So we could look at that and say that this one is the one that doesn't belong. Let's see, what else? This one, all the sides are the same length. This one, all the sides are the same length. And this one, all the sides are the same length. So that's another reason why this one wouldn't belong. What about this one? We don't have a reason why this one doesn't belong. Well, let's see. This one has all right angles all the way around. This one has all right angles all the way around. And this one has angles that are the same all the way around. So these 3 have all of their angles are the same. They are all equiangular. This one has some acute angles and obtuse angles. So that one doesn't fit for that reason. Let's see, what else? How many sides does this have? 1, 2, 3, 4, 5, 6, 7, 8. All right, so 8 sides here. You know what? Look at that. 1, 2, 3, 4, 5, 6, 7, 8. All the sides add up to 8. If I go 3 and 3, that's 6, and 1 and 1 is 8, and 2 and 2 and 2 and 2, that's 8. So this one also doesn't belong because it doesn't add up to 8. So that's a reason why this one doesn't belong. Let's see, what else? This one, let's see. Oh, look at that. This one is the only one that has even length sides. So this is 1's an odd number, 3 is an odd number, so these are all odd, and that is even. So that would be another reason why that one doesn't work. So I think we've come up with 2 for every single one. Oh no, not 2 for this one. Let's see here. Well, this one's kind of weird, but I noticed that this one is flat on the bottom, this one is flat on the bottom, and this one is also flat on the bottom, but this one is pointed on the bottom. It's kind of a cheap shot, but that one doesn't fit for that reason. All right, so great. Okay, it says use straight edge and compass tools to construct a square with segment AB as one of the sides. So we know that all squares have 4 sides. And just like up here, all 4 sides have to be equal in length, and they have to be right angles, right? This is not a square, obviously. So here we go. So I know that all the sides are this length. Well, I think in order to find something that is a distance that is the same length, I'm going to use a circle. So that means if I build the square going up, the other point is going to be on this circle somewhere. And I can do the same thing over here. So up here somewhere, there would be another point for each one of those. How am I going to get there? Well, we know that we can make a perpendicular bisector, right? And we can hit targets with lines and make them perpendicular to another line. So let's give ourselves a line here. Oops. Yeah, there we go. All right, so we've got a line. Now, so let's see here. I could just put a point anywhere I want. So let me put a point like right here. And that point I can use to make another point that's exactly the same distance away from B. Right? This point right here, which we'll name, we'll use this intersect tool to like label it, bam, is D. And I can say that it has to be the same distance away because it's one radius length away and it's on the edge of the circle. All right, well, I'm going to do the same thing over here. Well, no, I'll finish up with this side first. So now I have these 2 points, and they're both the same distance away from my target, which is B, because I want to draw a line that goes right down through there. So here we go. We're going to use our compass tool. We're going to make a perpendicular bisector using C and D. And then we'll do D and C as our radius the second time. And now we have these 2 intersecting points, top and bottom, right there and right there. And we're going to use the intersect tool to call those out. I'm just going to click on this circle and that circle, and that gives me those 2 intersect points, and that'll give me that line. Boom. All right, so now I know that this is a right angle right here. EBC is a right angle, or EBA, or ABE, whatever. It's a right angle. And if I want to make the square on top, and put my intersecting point up there, because A is the same distance from B as G is, right? From B out to G is a radius, and B out to A is a radius on the same circle, so those have to be the same length. Great, so now I have 3 of my corners of my square. I can do the same thing. I can do the same thing again over here on A. So I'm actually going to use the same exact radius. I'm going to use BC as that radius, and I'm going to put that right on A, and now I have 2 intersection points with this line that are the same distance away from A. That's H and I. And now I can make my perpendicular bisector using 2 circles. And again, I get these 2 intersecting points, top and bottom, right there. I'm going to call those out using the intersect tool. Click on those 2 circles. And now I've got my line going through A, and that is perpendicular to AB. And again, I have that intersection point up there. So here we go. L, G, B, A, and back to L again. Ta-da! There's a square. All right, cool. Next. All right, so it says for task 3, and we're doing this down here. It says, here is a square ABCD. All right, great, got it. ABCD. All right. Construct a circle centered at A with a radius of AD. Compass tool, always the compass tool. Centered at A with a radius AD. Okay. AD is my radius, and A is going to be my center. Then it says construct a circle centered at CD, centered at C with a radius of CD. Okay, same deal. CD is going to be my radius, and C is going to be my center. And now what do I want to do? Draw the diagonal AC and write a conjecture about the relationship between diagonals BD and AC. Okay, so BD is a diagonal. It goes diagonally across the square. And I'm drawing AC, so that would be a line segment. AC. There we go. So as I look at that, it says, how are these diagonals related? Oh, wait, sorry, I have to make this last circle. Label intersection of the diagonals as point E. Okay, so this spot right here where these diagonals cross is point E. So we will intersect that, and we'll say that that's E. There we go. All right, cool. So now it says construct a circle centered at E with a radius of EB. Okay, back to my compass tool. EB is my radius, centered at E. All right, cool. Well, check it out. It actually hits all of these corners. That's not all that surprising, right? It went from E to B, and E to D is also the same distance, and E to A is the same distance, and E to C is the same distance. They are all radii of that same circle. But they are saying, how are the diagonals related to this circle? So the diagonals are AC, which is this line segment all the way across here, and BD. How are these two related? Well, as I look at those, I say, you know what? If I compare them to that circle right there, if I go from E out to the edge, I notice that that's a radius. From E out to the edge is a radius. But if I go all the way across, what is that? Well, that's two radiuses, or also known as a diameter, right? That goes all the way across. If it goes through the center, it is a diameter. So that's what those are. AC and BD are both diameters of this smaller circle. All right, next one up. All right, use your conjecture in straight edge. So as I look at this, I think, right, up here it says, write a conjecture about the relationship between BD and AC. Well, they're at right angles to each other. We can say that, right? And they both bisect each other. And we can say that. We can say that for sure because E to A, E to C, E to B, and E to D are all the same distance because those points all lie on the circle and E is the center. So here we go. We're going to use that and we're going to make a square inside this circle. All right. Well, first things first, I'm going to need a point on the edge of the circle. So that's what I'm going to do. I'm going to use the point on object tool, and I'm just going to put a point right there. Now, how do I get another point on that circle that's in the right spot? I'm going to use the line tool. I'm going to hit the center right there, and that gives me this other point on the other side. And now I have a diameter. From C to D is a diameter. Just like I did up here, I had B to D as a diameter and A to C as a diameter. I'm actually going to try and make this same sort of situation here. I have one diameter. I need another one. This time it has to be at a right angle. I want it to be exactly a right angle. So I'm going to use the compass tool, and I'm going to create a perpendicular bisector that goes through this center of this circle. So the perpendicular bisector is based on 2 points that are the same distance from my target, and my target is that black dot right there. So there's my two circles and my two intersection points, which are, select these two, E and F. If I draw a line through there, I'm going to have two more points right here and right here that are intersecting with that circle. So I'm going to select those intersecting points between the circle and this line, and there they are, G and H. And I'm going to make a square that goes from C to G to D to H and then back to C again. And I can test it out to make sure that I did it right by grabbing onto, I could try and grab onto a lot of these points, but these are not going to move. These are locked in because I use the intersect tool in order to do them. Right? The only thing that I'm going to be able to change is C, and all I can do is move it around. Woo! All right? So it's a square whether I put C over here or down there or whatever. All right, great. Next. Oops. Not down there. Oops, didn't mean to do that. Let's go back over here. There we go. Task 6. Use a straight edge and compass to construct a square that fits perfectly outside the circle. Okay, so the circle is inscribed in the square. We talked about being inscribed, right? That's where the corners are all touching the inside of the circle, or the edge of the circle. Here, the edge of the circle is touching the sides of the square. So I'm going to start out the same way. I'm going to put a point on the edge of the circle here. I'm going to draw a line, and that'll let me find this other point on the other side. Now, why would I want that? Well, let's think about what we know about a square. What do we know about a square? We know that a square has equal length sides, right? And if we want to draw a square that's going to be on the outside edges of this circle, then it's got to hit the edge right at that point, either both C and D, which means that the length of this side up here is going to be the same as C to D. Same thing with down here. It also means that in order to go up, right, it's going to be the same length from whatever point is up here at this corner of the square down to the bottom at this corner of this square. That'll also be the same distance, which means that half of that distance is going to be above and half of that distance is going to be below. So basically, I'm going to create a circle with the same radius. I'm going to put it on D, which means that this circle from top to bottom is the same distance as from C to D, which is the length of the side of the square. So one of the points is going to be down here at the bottom of the square, about bottom of the circle, and one is going to be up at the top. Those are where the corners are going to be. But I don't know where exactly on this edge of this circle. Same thing is going to be true on the other side. So here we go. Let's just do the same thing we just did. And this time we'll put the center on C. Again, the corner of the square is going to be up here somewhere and down here somewhere. All right. So now we just need to come up with some lines that are perpendicular to this one, because we want something going straight up and down here and straight up and down here, and it has to hit D. We've done this a bunch of times. Trying to get a perpendicular line to hit a point? Absolutely. We just need 2 points that are the same distance from our target. Well, we know how to do that. So I'm going to put a point right somewhere in here, okay? And I'm going to use the compass tool to come up with another circle, another point that is the same distance away, right? D to E is the same distance from D to whatever this intersection point is. So let me label that other intersection point carefully and make sure I get it exactly right. There we go. So from D to E has to be the same distance as from D to F, because that's a radius. From D to E, that's a radius. From D to F, that's a radius on the same circle, so it has to be the same size. Now I can use my compass tool and make a perpendicular bisector that's going to hit D, because it's going to go halfway between E and F, right? To be a bisector means to cut in half, and we know that D is halfway between E and F. And a perpendicular bisector is perpendicular. It means it hits at a right angle, which is exactly what we want. So here we go. Make a circle here, and make a circle here. Notice I'm using that radius. My radius is the distance between E and F. And that gives me this intersection point and that intersection point. I'm going to call those out using the intersect tool. Boom. So G and H. So now I'm going to make a line through G and H. There's G, there's H, and I've got a perpendicular line. Great. So I know that this is one edge of my square. And actually, I know that this point is one of the corners of my square, and that point is the other one. So why don't I actually call those out right now? There we go, I and j. Those are going to be corners of the square. I just have to do the exact same thing I did over here on C. So we're going to do the same exact thing. In fact, I'm going to even borrow this radius from D to E, and I'm going to put the circle centered on C. So now this distance, let me call out these intersection points where this circle crosses this line. That's K and L. K and L are the same distance away from C as they are from C to L is the same as C to K. And because I stole the radius from over here, or borrowed it, or copied it, it means that from D to E is the same as from C to L. Pretty cool, huh? So now, and actually we can show that just by moving E around a little bit. You can see that the circles change size, right? This line is still perpendicular and it still goes through D, but it doesn't matter if I put E over here or E close in here. It doesn't matter. All right, so now using K and L, I'm going to make a perpendicular bisector that is going to go through C, right? I'm cutting this L and K line segment perfectly in half using a perpendicular bisector. Boom, and again I get these little intersection points right there and right there. Use the intersect tool, click this circle and that circle, and it'll call out those two intersection points, M and N. Make a line with M and N, and we've got the sides of our, whoops, hang on, I'm still missing some points here. This intersection point up here and this one down here are the corners of my square, the other corners of my square. There we go. So O and P, those are the other intersection points for the square. So let's see here. What do I need? I need this. Oh, I wanted to show you guys something. Actually, looking at this, this is the center of our square. It's not just the center of this circle, it's the center of our square. So watch what happens when I go like this. If I take this point here and this point here and I use that as a radius, look, my circle hits all these points. So I could have used that a little earlier on to identify these 2 points. I didn't have to select them here. I could have just made one circle and gotten those. But again, I still had to make this perpendicular bisector in order to know where those were going to cross. All right, so here's my polygon tool. We're going to make a square from here to there, to there, to there, and back to there. And notice that if I try to move anything, like, can I move C? Yeah. Is it still a square? Yes. All right. How about if I move E? I can move E. Doesn't change anything except the size of these other circles. All right, cool. And number 7, how do the areas of these two squares compare? Now they're talking about this square and the square that we made up here earlier that I accidentally erased. I'll quickly make it again. Oops. I'll quickly make it again so that we can see it. Again, I'm making this with using the perpendicular bisector, right? I'm going to cut through where these two circles intersect, and that will give me the corners where the square is going to hit on the inside on this circle. And then here's my square from C to G to D to H and back to C again. So how do the areas of these two squares compare? If I look at this and I look at that, apparently I just refreshed it. So just lost it all. That's okay. That's all right. You guys can rewatch it. I don't want to rebuild them. All right. Move on to the practice set. And that's it.